Hey guys,
Hey.
welcome to my AlTalk. I'm going to be talking today about React, Storybook, and snapshot testing, the benefits, and suggest a couple of things that may work out for you in your project. So let's dig in. So for starters, let's start by running a project, and I'm gonna show you real quick what this is about. So this is a very simple React application. It's a news feed. So in the news feed, you literally has a list of news, and you can read through them, maybe create a couple of news. That's pretty much the application. It's very simple. Now let's dig into our code base. So it's a React application. We're gonna see a couple of components. And before digging into what Storybook is, let's first take a look at what our components are and what they do.
Could you zoom
Zoom the text a little bit.
Right.
Increase the size.
Let me see.
Awesome.
One more, I would say. What is it right now? Yeah. Probably better, yes.
Yeah.
Okay. So we have three components in our application. We have a container component, which is a feed container. Then we have two other components, the feed and the post components. So let's start from the smaller one, which is the post component. So as you can see, let me zoom in. This is just let's start from the bottom. This is a React component. We usually start reading it from the bottom towards the top. You can see it's just a functional component. It receives a couple of props, and then it renders some JSX. Pretty simple. Then at the top we have our interface definition, but that's not relevant. Let's move ahead to the feed component. The feed component represents the actual box that renders multiple posts. For example, one of these is a post, and the goal is a feed. Let's go ahead and look what it looks like. It's not a representational component. It has a title, bottom, which are of course the ones at the bottom here, at the top, and then it renders some content. So let's see what the content is. So it can be of type post or error, and then we will render respectively what we should be rendering for our two UI states. That's pretty much it. That's our application. Last but not least, let's take a look at the feed container component. Container component, usually you will see it defined this way for the ones that use Redux. If you guys are not using Redux or whatever, you can of course manage the state however you want. I went for a quick class component just for demo purposes. So there's nothing much to see here other than the state is loaded, and then you render a presentation component. It's pretty simple. Now, one more important part is where do we get our data from for a post, right? So let's take a look at the API module, which is this one. And then we have a load post function that will return a premise. This is, we are right now emulating what we'll be calling the server API. So let's take a look inside the else. We will be resolving our promise with an array of posts. We have 6 posts. Simple. So let's go to what Storybook is and why is it helpful for us. Right now I'm a developer and I'm working on my application, right? And I'm working on this new story, which is the error state. So what happens if the server is down? We won't be able to see any posts here. So what's going to be rendered? Is our application going to crash? Is it going to render a blank screen? We don't know, but we do have acceptance criteria. So product owner want us to render a specific UI if the server is down. So what would be the painful usual process that developers go through to test this part? Okay, so we will go to either ways our API component or maybe the server side, and we will change the code, compile, to force an error. then when we reload, yeah, we now see what the error screen looks like. What's the problem here, right? We are altering code that has nothing to do with our change. So we have a lot of risk here by developing this practice. Of course, this was a simple change. I just literally changed a false to true, but on an actual large application, we will probably be doing something more complex to, to force an error on a particular endpoint. So the risks that I can see by, following this practice are maybe I forgot that I did this change and I end up committing my code with this change that was not supposed to be a part of the commit, and then I introduce a new regression that turns out to escalate to a new bug. That is on one thing. And this is also a painful process because then I have to remember that in order to see the screen or to see the actual state, I have to do some changes. This is not ideal. So what other options do we have, right? Manage the state however you want. I went for a quick class component just for demo purposes. So there's nothing much to see here other than the state is loaded and then you render a presentation component. It's pretty simple. Now, one more important part is where do we get our data from? Repos, right? So let's take a look at the API module, which is this one. And then we have a load post function that will return a promise. This is, we are right now emulating what we'll be calling a server API. So we have started Storybook, so let's see what it is in the browser. So this is a Storybook. Storybook is a tool, it's a development tool that will help us with the development, but from the UI perspective of React components. So this tool will, so it has a panel at the left side which has different links I can click on. These links will render components with different props that I have defined. So how can I use this to our advantage for this previous problem that I just explained, right? We'll go to stories and then let's look at the post. No, let's look at the feed stories. So the feed stories are these two. I have two UI state for my feed component, which is the UI state when I have a list of posts and the UI state when I have an error. So right now, this again, we're just rendering a component. This is not the application loaded. There is no network calls here. There is nothing plugged. This is literally just one component in isolation. So as you can see, I have my feed component rendered here with default props, which are all the ones that are defined here. We have like user, these are the list of posts, and then we have like a callback function, and then a type prop, and then for the other state, I have an error. This is how I emulate the error, or this is how I design how my component looks like when it gets an error as a prop. So this gives me the freedom of designing without having to alter code that's not really relevant for what I'm working with right now. Let's look at one more example, the post stories, and then let's look how many UI states can our post take. So this is a normal post. We have like the name, we have like the username, the avatar image, and then some description and maybe a date. Then we have a different UI state when our posts have an image. And then we have another one when I am the person who created the post. It's my post. And maybe I get a couple of buttons that I didn't when it's on my post, right? So we're able to, again, we're able to design these components in isolation in each of their own UI states. So this is cool and everything, but can we get more out of it? Of course we can. This is the important part. This is the whole the point of the presentation that I'm making, which is the unit testing part. So let's first run the test, right? And then let's run the coverage. So what's happening here is that I'm running my unit test framework, and I'm running some unit tests. And the unit tests are going to be shallow rendering my components inside the stories. So let's take a look at the feed component, and the coverage is 100%. And then let's take a look at the post component. The coverage is 100%. So we literally covered each line in the file. It's 100% coverage. So did we write many unit tests for this? We didn't. We literally just called one function, which is the feed story shots. This is the cool part about working with Storybook. So Storyshot is a plugin that will create snapshots, serialize snapshot out of your already defined stories. So basically, you don't have to go ahead, you don't have to go around creating new test case, then giving new prop, and then manually writing to match snapshot expectations that you usually see. Why is this better than doing it manually? Because you don't have to understand the preset of your component by reading code. You only have to look at it visually. This is the reason this is better than writing the expectations yourself. Now, don't take a look at this one yet. I'm going to be explaining the image snapshot later. Let's see what's next. Right. So, in order for this to work, as you can see, this feed container doesn't have 100%. This is not relevant here. The feed container is not even rendered in Storybook. Why? Let's go to the feed container. In order for this pattern to work, we need to be very, 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 very strict in the separation of concerns when it comes to presentation of versus container components. The reason is because from the point of view of Storybook, we don't care about states. We don't, even if you can hack your way through and change states of your components in a particular moment, that's not the point. The point is you only care about the UI space. So you only care about how it looks like when you give it some props. You put some input, it processes, it gives you an output. That's it. So we have to do a really straight separation of concerns when it comes to container components, so that we don't end up doing unnecessarily extra work just to make Storybook work. So what do we do in the case of container components? Of course, we go our normal way of just writing its unit tests. See how it looks like? Yeah, it's a normal unit test, and we can, of course, if we feel like we need, do a manual assertion for the container components. This is completely outside of the scope of what we want to be handling on Storybook. One more thing, again, Storybook and the whole snapshot testing using Storybook setup is purely structural. We care about the UI stakes. So what happens when we have some behavior, like a button click, or maybe like a DOM event? So for those, we of course have to create some manual tests, which are this ones. As you can see, we render our component, we do shallow rendering, or I am a shallow rendering advocate. You render the way you feel it's going to be best for you, and then you do a manual assertion for your prop to have in call. So that's how we handle the behavior. So the two important parts here are that we have, number one, we have to be very strict when separating presentation from container components. And number two, we will be testing manually behavior. So this is like the strong point here. Right, so let's introduce a new regression and see what happens. So we have our feed component here, and it says news feed. And let's say as I was working with the code, I accidentally added the criteria, acceptance criteria, should not be there. Of course, this is a low priority bug, low impact, but still a bug. So if we go to our Chrome window, we're gonna have an S here that was not supposed to be here, and of course we're gonna have it here. It's cool. When we run our tests, it's going, of course, to fail. when we check out what failed, we'll see that the serialization was expecting not to have an S, and we now have an S. So very simple. So yeah, this is, everyone knows this. This is old story about how serial snapshot works. That's okay. Let's revert the change. What happens when we do different type of change, such as CSS change, an unwanted CSS change. So what actually happened was that if we go to the inspector here and we go to the bottom, we see that we now have a 5-pixel padding that was not supposed to be there. That's also a bug. But how can visually, like by looking at it, it's really hard to identify that you had an extra padding because it's really minimal, right? How do you catch these regressions and stop them from going to prod? This is where the image snapshot testing comes in. So besides the serialization that we have, let's just go to the component. Let's look at the close one. We also have another one for the image snapshot test. Let me first show you what this is about. So this is my directory. This is the directory of my code base. You guys here you can see the file for the code. Then there's also this image snapshot directory, which has a literal snapshot, like a PNG image, PNG image of every component that I have in storybook. This is of course committed to our code base, and then we can, when we check out or any other developer check out the code base component, they will have these images. That's regular. But then what happens if we did the change and now we run all of our tests with this new regression. So as you can see, the serialization part passed. Why did it pass? Why we didn't get a new serialization or a new error in the test with the serialization components? Because this is CSS, and you don't get CSS in a React component. The CSS is completely loaded by the browser itself. So even if you add a new regression through CSS, that you can clearly see here, the bottom doesn't have the correct padding, your serialization components are not going to be catching the error. So that's where the image snapshot comes in. You see I have these two errors, and this one comes from the image snapshots test suite. And when we go here, we'll see a div output directory, which will have an image div of what changes. So on the left side, we have the previews part, which is how it looks at the very beginning. And the right side here, we have how it looks now that that the test cases failed. And in the center, you have an image that's sort of white, but then you have a red part here. This red part is a pixel difference that was captured. So this is how you catch visual regression tests.
I have a question. So the generated images that you had before, who generated and improved them? Was it the automated continuous integration, or was it a person that said this is how it should look and approved it and generated?
That's a very important question, and the answer goes by analyzing what's the actual process. So as a developer, you're an author. You are responsible for making sure what you commit into the code is correct. So it's your responsibility to approve whether this change is okay or not. So our test framework is failing, but doesn't mean it's wrong. What it means is that a change was found that wasn't there before. So your job is to open this file here and then asking yourself as an author, did I intended to make this 5-pixel padding change or not? If I did, then I can just update the images. Just press the U button, they get updated. If I didn't intend, then I have to stop and then see why this regression was made, fix that, and then come back and run the test suite once again. That's pretty much what I wanted to show you guys. As a summary, serialization tests are important for HTML or JSX changes. Image snapshot tests or visual regression tests will be important for CSS changes, for example. And you can, of course, get, by using this this setup of storybook, strictly separation of presentation on container components, and the story shots add-on, you can get 100% coverage in the React component without writing a single test. Of course, even that they don't have behavior. But yeah, this greatly increases productivity in the development team, as you don't have not only to be reading the test, but you don't have to be not only you don't have to be writing tests manually, but you also don't have to be reading tests that were written by someone else. That's also a benefit. It's all about optimizing the development process.
Thank you very much.
Any questions?
I got two. First one, is this project shared anywhere that we could use it or steal from it or stuff like that?
I can totally, upload it to my GitHub and you can just check it out.
We'll put it with the video so that everything is there, link to it and all of it.
And the second question is, you've been talking about how you're able to get 100% coverage without writing a single individual test, but in the same breath you also mentioned that it doesn't cover behavior. Because the behavior portion is usually separate in code from the visual portion of the component, will the coverage be correct in saying that these lines that are related to behavior, for example, you didn't call this function, is that something that's going to be represented correctly in the coverage report?
It is, yes. So again, the 100% coverage without writing a single test is kind of like a clickbaity title. It is technically true if your component doesn't have behavior. If it does, then you will have to, write the test for the behavior yourself, which is what we saw in the fit test file here, where I have the suite for serialization, and then down below I have the manual test for the behavior. Yeah. So if you don't write this test here, what's going to happen is that the coverage will drop because your. Let me show you exactly why it's going to drop. So when this function here is never getting called when you run your stories, because this function only gets called when you click on the button.
Correct.
So your story shots, they don't click on anything. So this part, the coverage will drop. The percentage of dropness or how much it's going to drop, I have no idea. I haven't really checked. It's not really relevant. All that we care is that we're not 100% because we missed a couple of lines.
If you remove that test, what happens?
Let's see. And also let's remove the CSS change so that it doesn't crash. There we go. Alright, I don't know why it has 100% coverage, but it shouldn't. Actually, I think I know why. Probably because I made some mistakes with bits. Here should be a function. Yeah. Yeah, that's right.
So if that goes through, it would mean that the text. Yeah, there you go. No?
Nope.
No?
Yeah?
Okay,
No?
it's me. I don't know, this is a quick demo. Yeah, I just probably missed something. But like on the real
Well,
project,
on their tests, it was one skipped. Is it the same one for feed container or
this is the one that I skipped. But what should have happened is one of these ones. should
drop the
have-
percentage?
Yeah, drop the percentage. I really can answer with the quick demo. I do know from the actual project that this is something that I found out. So maybe I just missed something in the setup here.
Okay.
So how would you test a model?
Sorry again.
How would you test a model?
A model.
Yeah.
In what aspect?
Sorry, so there's a problem with models that they are not on the same, so you cannot do them on a shallow render. That's the reason we do it on each because if you try, they are actually rendered outside what you are actually shallow rendering, a model. So how would you test that with serialization on a straight?
A model. Why couldn't you test a model?
So I think that's very particular to Material UI since they use the portal component to be able to do that.
Yeah, but it's not only material, there's a lot of things like you said. So there's the whole moral idea was designed based on that.
Yeah.
So basically, you're rendering the model outside of the page.
Exactly. So let's say you have your frame, your div. Now your model is not going to be rendered on your div because it has to take the whole
Sure.
screen. So it actually goes ahead and it gets rendered on the bottom of the page.
And then it gets moved up.
But I don't see why couldn't, because
Because you're shallow rendering. If you're shallow rendering, you're just doing it on one level, on a div, But the model does not work under that div. It goes away from that div, outside of the whole UI to
But-
actually straight up.
so the model is written in a way where you in your application you have to put it somewhere in your let's say in the SRC index, I don't know, like or maybe in the HTML file, I don't know. Let me show you what I mean. So maybe you have like a complex here wrapping up. Maybe you have like many of them, and the model is outside, something like that.
No, it's within the body, but the whole concept of portals is because models on every design is an exception because of the overlay. Because you cannot render it to take the whole screen and the overlay if you're shallow rendering on one inside one component. So even though if you go ahead and you create a React component for a model and you put it inside one specific component, when that component actually gets rendered, it's gonna go outside that component and
Yeah.
take itself.
Yeah, it's going to be rendering as a whole.
Yeah, exactly.
But from the storybook perspective, all you care about is
The visual part of the model.
the visual part of the model. So as long as you're able to pass it like this, like you pass model and then the props, it's still going to get rendered in the.
No, it won't because again, it's not shallow. The problem is shallow rendering.
But
Again-
if you're passing the portal part as well to Storybook, that's where you're gonna get messed up. But if you passing the component that's under it, the actual visual
Oh,
component.
you mean only the div within the model. Okay, so you cannot actually test the model as a component. You have to test the contents of the model.
Which is the only thing relevant for Storybook.
I think you should be able to still test the model. I mean, if you have different things like, for example, accessibility, that you have to handle like key events or something, you can also do that by abstracting those away in higher components. For the case of the model, in fact, let me see if I can just show you one from Anaplan, I guess.
Great.